Hello, we're going to continue our work in percentages now, and today is focused entirely on something called the unitary method. The unitary method is where we have a question and we find out what 1% of what we're interested in, and then we multiply up to find out what 100% of what we're interested in is. That's the method we're going to keep using in a few different contexts. So let's jump into our first example. Decrease €200 by 25%. So 200 euro is 100%. It's what we are starting with. It's our starting point based on the information we're given in the question. So it's 100%. It's kind of our default. We want to decrease that by 25%. So we're at 100% and we want to decrease by 25%. That means we want to end up at 75%. So that is our goal. That is what we are after. So the way the unitary method works is if we know 100% and we want to find out what 75% is, we take 100%. This is our 100% situation. We find out what 1% is. How do we do that? Well, we divide both sides by 100. If 100% is 200 euro, then 2 euro would be 1%. So this is how we would reason it out. This must be true. And structurally, we can say we can divide both sides of our relationship, of our ratio. This is actually an equation, but as we can think about it as a ratio, we can divide both sides by 100. And we are left with 1% is 2 euro. But I don't want to know what 1% is. I want to know what 75% is. So what can I do? Well, if I know what 1% is, what could I multiply by to get to 75%? I could multiply by 75. And if I do it to one side of a ratio, I must do it to the other side of a ratio. Just like when we're dealing with the top and bottom of fractions, we must keep things balanced. So when we do this multiply, we know we're going to end up with 150 euro is going to be 75%. Now there are other ways of doing this question which may occur to you. You could get 25% of 200 and then subtract it away. The reason for the unitary method is it will work in every single context, and other methods that we could use, which are easier for this particular example, do not work well for more complicated examples. So the unitary method will always work, and it's the method we're going to focus on because it's always going to work. It sets us up for success in the long run. So let's put it into practice again. I want to increase 40 euro by 15%. So 40 euro, based on the way the question is described, is 100%. It's my default. It's where I'm starting from. And I want to increase it by 15%. So I want to go from 100% and I want to get 15% bigger. So I want to go up to 115%. That's my goal. This is where I'm at. So how am I going to do it? I'm going to get 1%. So divide both sides of my ratio by 100. Process will always look fairly similar. For the simple questions, it will always look basically identical. When I divide this, I end up with 0.4 euro, or 40 cent, is 1%. And I want to know what 115% is. So when I do that multiply, obviously I'm at 1, I want to get to 115. I'm just multiplying by 115, and I must do the same thing on the top of my fraction, or on the other side of my ratio, to keep everything balanced. And when I do that multiply out, I will get 460, apologies, 460 euro is equal to 115%. So we can see how this is going to work. I figure out what 100% is based on the context of the question. I figure out where I want to end up. Then I set up my ratio or my equation, and I am able to find out what 1% is and then multiply up to whatever percent I am interested in. And this will always be how we will approach any type of more advanced percentage question. So let's look at a different style of question and see if we can figure out how to implement it. 16% of a number is 80. What is the number? Well, now we have a different starting point. I don't know 100% this time. I want to find 100%. So 16% of a number, 16% is 80. Well, is another word for equals. So 16% of my number is 80. And I want to know the number. Well, how would I say that in terms of percentages? I want to know what 100% is equal to. So what I'm going to do is start with what I know, and I'm going to find out what 1% is, and then find out what 100% is. Very much the same type of idea as we had here. We just have a slightly different starting point. So how am I going to get 1%? 16 divided by 16 is 1. I must divide by the same thing on the other side of my ratio. So 1% is going to be 5. And then what is 100%? Well, if I know 1% is 5, I know that 100% is going to be 100 times bigger. So I multiply both sides by 100. And I know 100% is going to be 500. So again, we set up what we know, figure out what we're looking for, divide so that we end up with 1% of what we're looking for, and then multiply by 100 to get up to what we were looking for. Or multiply by whatever we want to get up to whatever percentage we're interested in. Let's try another one. 56 euro is 14% of my money. How much money do I have? Okay, so I have 14% is my 56 euro. So I want to know 100%. What is my amount of money? Well, my amount of money is 100% of my money. So I want to know 100%. Same setup as we had here. So we have 14% is equal to 56 euro. I want to find out what 1% is. So 14 divided by 14 will give me 1%. And I must do the same thing to the other side of my ratio. So 1% is going to be equal to 4 euro. And then I want to know 100%. In this case, I've put brackets in, so I'll just complete that. I'm multiplying by 100 to get up to 100%, because that's what I decided I needed in this question. That's what I figured out I needed in this question. So that's how our unitary method works. Now, can we apply it in a slightly more challenging context, in a slightly more challenging problem? After a sale, a shirt's price increases by 40% to 70 euro. What was the sale price? 70 euro is a very expensive shirt, but it works as an example. So, after a sale, a shirt's price increases by 40% to 70 euro. So what do I know? The 70 euro is what percentage of the sale price? Sale price is what I want. And I know that the price has gone up by 40%. So that means the sale price, if the sale price, I have to tell myself a story now, the sale price was 100% because I've been told how something changed percentage-wise relative to my sale price. So my sale price is what I'm after. It was increased by 40%. So that means I was at 100% during the sale, and I increased it by 40%. So the current situation is 140% of the sale price. So 140% is equal to 70 euro. The current situation has gone up by 40% and it's €70. So this is the situation I've got. And this is what I want to find. I want to know the sale price. So I'm looking for 100%. So now I've done this setup. Let's see what we can do. I'm at 140. I want to find out what 1% is and then multiply up to get 100%. So I need to divide 140 by 140. Any number divided by itself is just going to give me 1. So I'm always dividing by whatever my percentage is to get 1%. 70 divided by 140 is going to leave me with a half, or 0.5 if you prefer a decimal. And now I want to get up to 100%. So I need to multiply the percentage by 100, and to keep everything balanced I must multiply the other side by 100 and my ratio by 100. So 100% is half of 100 is going to be €50. So the sale price of that shirt was €50. So we can see that this way of doing things works in lots of different circumstances. So that's its advantage. It will work in lots of different places. This unitary method will work very well in lots of different contexts. So that's why we need to get really good at it. And that is what we need for now.